Welcome to your Intro to Stat Lesson 1.3. Today we're going to learn to use histograms to display quantitative data. Histograms and exploration of data and graphical displays is part of exploratory data analysis, or EDA. It's a technique particularly useful for detecting patterns and extreme values. It's just looking at the data and seeing what they tell us, okay? Seeing what the story is. What's the pattern? What's typical? What do we expect? And then which values break away from the pattern. This makes uses of histograms and other graphics. We're going to learn several more graphical displays over the next couple of lessons. A graphical display, whether it's a histogram or anything else, should show the data, obviously, induce the viewer to think about the substance of the graphic, and avoid distorting the message. We want to be truthful in what we are displaying. So the rules for any graph would be to provide a title. You need to let people know what they're looking at. That's part of getting them to think about the content. You want to label the axes so it's clear which values are, what the different values represent. Identify the units of measure to give a sense of scale and present the information clearly, because that's the whole point of having a graph of your data. Okay, so histograms in particular. A histogram is a visual display of data organized into a frequency table. Bars represent each class. The height of each bar represents class frequency or relative frequency if it's in percents. In other words, it's telling you how often an observation fell into the range of data included in the class for that bar. The width of each bar represents the class width, and it's important that that remain constant from bar to bar. So to construct a histogram, we're going to use our CAS calculators. You're going to enter the data into a named list in a list and spreadsheet page in a document. So you have to go to Document, open New Document, and then select List and Spreadsheet page. Then go to, and so you're going to enter the list, and you're going to name it just like we've done before. And then you're going to go to Doc, because we want to add a page to our document, and you're going to insert a Data and Statistics page. Anytime you're doing a graphical display of data, this is the type of page you want to insert. Then you're going to click on the horizontal axis and add the variable associated with the list to this horizontal axis. So whatever you named your list, that's what is going to show up as an option, and that's what you're going to select. You're going to go to Menu, and then Plot Type, and then Histogram. So here we're doing something within the page that we already have, and so we select Menu. Whenever you're adding a new page, you go to Doc, just to kind of help you internalize this, because you're going to need to know how to do this without any list of instructions. Okay, so here we have an example. The following are the weights of 15 woodchucks in pounds. And so we've got 15 different little weights there of woodchucks in pounds. We're going to use our CAS, and we're going to make a histogram of woodchuck weights. Now, whenever you're instructed to do something like this, you are going to create it in your calculator, but then you're going to have to be able to draw it on the piece of paper also. So you'll need to make sure you include all those details listed in the rules for the graph whenever you're writing, whenever you're copying what you see in your calculator onto your piece of paper. All right, so the first thing we do is we open up a new document. I went ahead and named it Woodchuck Weights. And then I created my list here, and I named I could have named it weight, I named it pounds. It doesn't matter. You could name it Woodchuck Weight, you know, however you want to name it. It needs to be relevant to what you're putting in here, so I would suggest weight or pounds. And I went through and added each entry into the list. Now I was ready to do Doc, Insert, and I picked Data and Statistics. And the first thing that comes up is just this meaningless, just collection of all the points in the, all the values, excuse me, not point, but all the values in the list. Once I click, see right here where it says click to add variable, I hover there, and then I select the pounds. Okay, and once I do that, it organizes the data into a dot plot. So here's a nice dot plot of the data, but we want a histogram. So here's where you would go to Menu and select Plot Type, and you would select Histogram, and here's what we end up with. Well, that's pretty good, but the class widths are really small, and so it's hard to kind of see the overall pattern. So I manually change the class width, so I don't like it. I'm going to go to Plot Properties and change the bin width to 1. Okay, so instead of it going 4.5 to 5, 5 to 5.5, it's going to go like it's only the width is going to be 1 whole unit. I will go to the window and zoom data if needed. That's going to be how you get your window to fit whatever you have going on in your data if you change the plot properties. Zoom data, because we're working with data. So when I do that, see now it goes from 4.5 to 5.5 instead of 4.5 to 5. So I made the bins wider, and it gave me a nicer picture where I can see the overall pattern. All right, common shapes of histograms, because I can tell the shape really clearly from this. This is skewed right, and you'll understand why in just a minute. There are several common shapes of histograms. They can be symmetric or symmetrical. Your book uses the word symmetrical. Other books use the word symmetric. Uniform or rectangular. They can be skewed left or skewed right. Skewed left means they have a tail going to the left. Skewed right means they have a tail going to the tail going further to the right. Or bimodal, that means they have 2 peaks. So let's look at what these look like. Here's a typical symmetric histogram. Okay, so you can see the tails look the same on either side of the peak. That is a typical symmetrical histogram. A typical uniform or rectangular histogram is also symmetric because both sides from the center look the same, but what makes this different, the reason it's uniform or rectangular, is every height is the same. You have the same frequency of every class. Skewed histograms, one that's skewed left is going to have a longer tail going to the left, and one that is skewed to the right is going to have a longer tail going to the right. Okay. Frequent misunderstanding students have is that the direction of the skew is where the peak is. That's not true. It is the direction that the tail trails. Okay, so if the tail trails to the right, it's skewed right. If the tail trails to the left, it's skewed left. A typical bimodal histogram, that bi means 2 and mode means where something happens most often. So it means 2 peaks, literally. So here we have a 2-peaked histogram, so that is a bimodal histogram. Okay, that's it for lesson 1.3. Do the problem to try on your own. Thank you for taking good notes, and I will see you in class. Have a great day.